Hi, I'm Nikki from Educating Now. Thank you for joining us while we explore Place Value Part 2, Ordering Decimal Numbers Using Base 10 Blocks. The goal for this lesson is for students to be able to really understand the relationships within the place value system, which is the same goal that we had for Part 1. For the Accessing Prior Knowledge part of this lesson sequence, you will need to start by identifying the largest cube as one whole. Because the focus of today's lesson is on ordering, we want to have as many decimal places as we can. So I would ask my students, after I named the largest block as one whole, to name all of the other size blocks. You can write a legend on the board or have students write their own legend on a piece of paper, naming all of the blocks using decimal notation, fraction notation, and even percentage notation if applicable. For the processing part of this lesson sequence, ask your students in partners to explain how they order decimals and why they do what they do. At this point in the processing part of the lesson sequence, I would give my students the following sets of numbers and ask them which they think is larger and why. They can either use blocks or words to explain their choices, but I do want them to really understand the choices that they are making. And I like to listen carefully to their explanation as it gives me a lot of information about the depth of their understanding. Again, here we want to be very careful about our language. When we look at the first example, we're not going to call this decimal 912 or 0.912 as many students would like to call it. We're going to call it 0 and 912 thousandths. This one would be called 219 thousandths. You could have a little bit of a discussion with your students at this point if need be about why we call this thousandths rather than tenths or hundredths. That again will give you a sense of where their level of understanding is. If we compare the two numbers using base 10 blocks, it's very clear that 912 thousandths is quite a bit larger than 219 thousandths. You could ask your students why that is. Using the blocks, they can explain that 912 thousandths has 9 tenths, 100th, and 2 thousandths. And because the tenths blocks are so much larger, the fact that we have 9 of them makes a significant difference. Versus 219 thousandths, we only have 2 tenths, 100th, and 9 thousandths. And because the 9 thousandths are the smallest of the blocks, they're quite insignificant when compared to the fact we only have 2 of the tenths. You could also use benchmarking to help them estimate their answers. 912 thousandths is really close to our one whole if we were using our largest cube as one whole, whereas 219 thousandths is actually closer to 0. I find many of my students are able to do the first one very quickly because they think of this as 912 and this is 219, which is fine as long as they are understanding it's 912 thousandths and 219 thousandths. Looking at the next one, some of them consider this to be 9 and this to be 901. So they still might correctly identify this as the larger of the two, but if you listen to their reasons, it might show that they don't really understand. Again, let's take a look at part B using the blocks. So here we have 9 tenths. Here we have 901 thousandths, which is also equal to 9 tenths, 0 hundredths, and 1 thousandth. You could talk about why we call this 901 thousandths if they're still not quite understanding by explaining that if we were just using the little blocks, we would need 900 and one of them to make up this entire stack. I find it is usually this third one that causes students problems if they don't really understand this concept yet. Here, they will consider 28 to be quite a bit bigger than 3 if they are not considering that this is 3 tenths versus 28 hundredths. So again, if your students mislabel and think that this is larger than this, you'll ask them to use the blocks or explain in their words their thinking. The blocks really help to show why this one is larger than this one. Some students have a hard time with the abstract, and when they're just looking at the numbers, It's very confusing for them as they really want to believe that 28 is larger than 3. So let's take a look at this one using our blocks. So here we can see that 3/10 just uses 3 of our tenths sized blocks, whereas 2800ths actually only uses 2 of those blocks and 8 of our hundredths blocks. You could ask students, what could we add to 2800ths to make it equal to 3/10? And hopefully they could see that 200ths added to my 2800ths would make it equal to 3/10. Using the blocks will help them because they often get confused with tenths, hundredths, and thousandths being in the reversed order in terms of size when they're working with decimals. Some students really want to think of thousandths as the biggest blocks, even though when we're working with decimals, the thousandths are obviously significantly smaller than both hundredths and tenths. After you've gone through several more examples like the ones we've just covered, I would ask my students to use partner talk and discuss what they understand about the place value system and any of the patterns or relationships that they discovered today. After they've had a chance to share with their partners and then share aloud to the whole class, I would ask them to do a small piece of writing in which they explained the patterns that they found and their understandings of the place value system. For the transforming part of this lesson sequence, I would have my students practice ordering different decimals using a variety of different strategies. First, I would have them using different types of dice. Here we have some deck of dice that are in tenths, hundredths, and thousandths. Students can roll the dice, write down the number that is created when they combine the 3 dice, and then give the dice to the partner who will roll and do the same thing, and then they can see whose is larger. You could also play a similar type of game with cards, having each student flip 3 or more cards and saying which number is larger, theirs or their partner's, as well as how to say the number if this is working in the decimal range. We want students to really have that practice of calling this 536 thousandths rather than 0.536 or decimal 536. For the reflection part of this lesson sequence, I would ask my students what they think is the most important thing about the place value system and why. I would also ask them how using the base 10 blocks affected their understanding of the place value system. Thank you for joining us at educatingnow.com while we explored place value using the base 10 blocks.